So in this last video of the unit, I'm going to discuss the material conditional. The material conditional, that's the name for the arrow in our system. And the arrow in our system, the conditional in our system, works differently than the conditional in English. And it's really helpful. You want to understand what it means to understand our language, and it's really helpful in doing derivations. So, in thinking about derivations. So these two arguments, Q, therefore P, then Q, and not P, therefore P arrow Q, are both valid in our system. If the premise of if either has a true premise, then that one has a true conclusion. And this is what characterizes the conditional as the material conditional, as I'm going to explain. And the conditional in English does not work like this, as we'll see. So the meaning of arrow, so P arrow Q is false if P is true and Q is false, and otherwise P arrow Q is true. So one way of thinking about that is it says that it's saying that P arrow Q has no counterexamples. So in other words, if we ask, is it the case that the antecedent is true but the conditional is false? Then no. But that's all that it says. So there are lots of ways that there can be no counterexample. It could be that both P and Q are true. It could be that P is false and Q is true, or P and Q could both be false. But in all of those cases, there's no counterexample to the arrow, and so to P arrow Q. And so as we're understanding P arrow Q in our system, and that's the conditional in the logical system, and not the conditional in English, we're talking about two different languages. There's the language English and the language of our logical system, and right now we're talking about the language of our logical system and what symbols in it mean, which are not necessarily the same thing, and as we'll see, definitely are not the same thing as some symbols in English. So the meaning of arrow works like this. If P is false or Q is true, then P arrow Q is true, and otherwise P arrow Q is false. And if you have a conditional with a meaning like that, you call it a material conditional. Why? We're not going to worry about. So we could do something that are called truth tables for the symbols in our language. So suppose we have P and then we have not P, and suppose that P is true. Well, what does that mean that the truth value of not P is? It's false. On the other hand, suppose that P is false. Well, what's the truth value of not P? It's true. And similarly, we can do a truth table for the conditional. So if both the antecedent and the consequent are true, then the conditional is true. If the antecedent is true and the consequent is false, the conditional is false. If the antecedent is false and the conditional is true, if the antecedent is false and the consequent is true, then the conditional is true. And if the antecedent and consequent are both false, then the conditional is true. These are called truth tables because they display in a table form the way in which the truth of a complex sentence depends upon the truth of its constituents. And we're assuming in laying this out that sentence letters are either true or false, but not both true and false, and that they're at least true or false. You don't have cases where P is neither true nor false. So we'll come back to truth tables in chapter 2, but they're just a nice graphic way to display the way in which the truth of a complex sentence depends upon the truth of its constituents. So continuing the discussion of the arrow, we know that if P is false, then P then Q is true. We know that if Q is true, then then P or Q is true. And so these two arguments are valid. Arguments 2 and 3. Now, let's consider English conditionals for a minute. I want to contrast English conditionals with the conditionals of our logical system. So suppose we have, if I exercise this year, I will be fit. If I don't exercise this year, I won't be fit. And if I don't exercise this year, I will be fit. So it seems like A and B are true, and C is false. Yeah? Okay. Now, that's fine. Let's look at B and C. So C seems false, and why? Well, because I need to exercise to get or stay fit. If I don't exercise, I'm not going to be fit. Part of what makes me fit is my exercising, insofar as I am fit. So suppose I do exercise this year. Well, that means that if that supposition in that case, C is a conditional with a false antecedent. But it's still false, right? C is a false conditional with a false antecedent. I exercise this year. Does that mean that C is true? No. C talks about what happens if I don't exercise this year, but I am exercising this year, and so that doesn't. The fact that I do exercise this year doesn't make C true. C isn't concerned with, as it turns out, with what's actually happening. It's concerned with what happens if I don't exercise. And so, in English, what we can see is that when a conditional has a false antecedent, does that mean the conditional is therefore true? No. Maybe the conditional is true, but not necessarily. Falsity of antecedent isn't enough for a true conditional. But in logic, having a false antecedent is enough for a conditional to be true, as we just saw. So there's a difference. In English, if the conditional has a false antecedent, is the conditional true? Who knows? Maybe, maybe not. In logic, if the conditional has a false antecedent, is the conditional true? Yes. So we have this contrast between the way in which the conditional in English and the conditional in logic the way in which the truth values of those conditionals depend upon their constituents. And similarly, there's a similar thing with the consequent. So in logic, as we've seen, if the consequent is true, if the consequent of a conditional is true, then the conditional is true. But that's not the case in English. So as it turns out, natural language conditionals are very complicated. They're really useful, but they're also really complicated, and it's very hard to describe the conditions. They're called indicative conditionals. That's just what they're called. And it's very hard to describe the conditions under which a conditional in English is true. So one basic idea, you might say, okay, well, if blah, 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 then blah, 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 is that true? Well, you ask, how likely is the consequent to be true given that the antecedent is true? And the more likely the consequent is to be true given that the antecedent is to be true, the more true we say the conditional is. But that's just a sort of very much a sketch of an idea, and we're not going to need to explore that. If the conditional in logic is so different than the conditional in English, in most cases, why would we use this material conditional? When we say the conditional logic and works like this, when we say here's how the conditional in logic works, that doesn't mean we have to do it that way. We could say, no, it shouldn't work like that. I don't want it to work like that. Let's change it. Just because it's in logic doesn't mean, just because we laid it out that way doesn't mean we should have given the arrow the meaning that we have. So why do we do that? Well, there are reasons. So why do we use it? Why do we use a system in which if either the antecedent is false or the consequent is true, the conditional is true, and if the antecedent is true and the consequent is false, then the conditional is false? In particular, why do we use a system in which the first is true? Well, a couple of reasons. First of all, it's simple, and we want to keep things simple and then build up to complexity. That's a theme we've seen returning. Also, in more complex systems, those systems aren't contain our system. So it's not just that it's simple, it's that it's contained in the more complex systems. They just do more. And the other thing is that a lot of reasoning in language does use the arrow, or it uses a material conditional. So in mathematics, in parts of law, in parts of the sciences, the arrow is what is probably meant by the conditional in English. So while in lots of cases in natural language, the English conditional is more complicated than the arrow in logic. In not all cases. There are important cases in English where probably the meaning of the arrow, the material conditional, pretty much captures the meaning of the conditional as it's used in English. So that's a sort of discussion of a divergence between part of natural language, if-then, and the logical language, if-then. This is relevant to doing derivations. When you're doing a derivation, the goal is to box and cancel. And to box and cancel, so by ID, as we saw previously, all you need is a contradiction. It doesn't matter where it came from. It doesn't have to have come from the assuming that the conclusion is false. And similarly, to box and cancel by CD, all you need is the consequent of the conditional. It doesn't matter how you get it. So you don't have to show that the antecedent connects to the consequent, because that's not required for our conditional to be true. And so when you're thinking of, well, make one more point. Remember also, you can always write show if circle then square, and if you do, you can always assume square. And if you happen to have not circle, then you can bring not circle down, and then you can box and cancel by indirect derivation. And what that means is that you can, if you have not circle, you can always get to the conditional circle then square, because you can write show the conditional, assume the antecedent, bring down the negation of the antecedent, and you have an indirect derivation. So the fundamental point here is, when you're trying to show a conditional, when you're working with a conditional, you want to remember that because it has this slightly funny meaning, a meaning that we may see sometimes in English but lots of times not with the conditional, it's flexible, and you can be flexible with your use of it in derivations. You can, if you get the consequent, you're done. However you got the consequent. If you get the negation of the antecedent, you're almost done. However you got the negation of the antecedent. So that's the key thing, is because it's a material conditional, you can do these things that we've talked about doing. And if you're not clear about that, and you're not clear that, and you're thinking of the conditional like it was an English conditional, you might not see that these are possibilities in the derivation system, or they might not be sort of at the top of your head when you're doing derivations. So this is the end of Chapter 1 and the end of Unit 6. In Chapter 2, in Unit 7, we're going to expand our language by adding some new sentential connectives. And so we'll see what those are like in Chapter 7. In the meantime, in Chapter 2. In the meantime, happy deriving and symbolizing, and perhaps I'll see you in office hours.